Okay guys, so today we're going to be looking at trigonometric identities. Next year you're going to be expected to memorize all of these, but for this year we want you to just understand how they work, and we're just going to expect you to be able to apply them. Some of them will seem very familiar, some of them not so much, and we just want you to kind of be introduced to them and understand where they came from. So the first one just says that cosecant theta is 1 over sine theta. We already knew that, right? They're reciprocal functions. Secant theta is a reciprocal of cosine, so we can think of it as 1 over cosine. Cotangent is 1 over tangent, because they're reciprocals. The tangent and cotangent identities, we haven't really talked about this much, but let's take a look at why this works the way it does. So let's say that we have the unit circle here, like this. And I have that this is going to be my adjacent, and it's also my x, and this is going to be my opposite, it's also my y. Tangent is always going to be opposite over adjacent, which is y over x. But we've also learned that in the unit circle, y is equal to sine theta, and x is equal to cosine theta. Remember how we talked about that? If we have that unit circle and we have that point there, that the x value is cosine and the y value is sine when we have that ordered pair. So therefore we know if tangent is y over x, it's also going to be sine over cosine. We know that cotangent is normally x over y, but we can also think of it as cosine over sine. So that's where those two come from. The other way we use the unit circle is for these Pythagorean identities. So looking at this unit circle again, if I use my Pythagorean theorem, I could say that x squared plus y squared has to equal, what's the radius in the unit circle? 1, right? So x squared plus y squared must equal 1. But what have we said x is the same as? Cosine. So now we can say cosine theta squared plus sine theta squared has to equal 1. And that's where this first Pythagorean identity came from, is because we're simply using the Pythagorean formula with these values. Now, we don't have to just let that hypotenuse be 1. We can let that hypotenuse be anything we want. It could be 2, it could be 5, it could be, I could divide this whole triangle by x. Let me redraw the triangle down here. That same triangle, we just said it was x, y, and 1. Well, I can change it. I can make it whatever I want as long as I'm consistent. If I want to, I can divide every side by x and make a new triangle that's similar to the first one. I'm going to use the Pythagorean theorem again. What's x over x? 1. What's y over x? Y over x is what? Is it tangent or cotangent? Tangent. So y over x is tangent squared. So 1 squared plus tangent squared has to equal 1 over x. And what's 1 over x the same as, guys? It's secant. Because x is cosine and 1 over cosine. See, let's write this even. Secant is 1 over x, because we know cosine is x. Sine is 1 over y. And this, I can't really write that one. Okay, so see how we get this next identity? All right, let's go for the final identity. What else could I divide this triangle by? Instead of x, I could divide it by y. So I divide this by y, this by y, this by y. What's x over y? It's cotangent. So you have to know these. Cotangent is x over y, because I can also think of it as cosine over sine. So that's why it's x over y. So we would now have x over y is cotangent, so cotangent squared plus y over y is 1 equals 1 over y. What's 1 over y? Cosecant squared. So see how then we get that last identity? 1 plus cotangent squared equals cosecant squared. That's where they all come from. I never memorize something that I can figure out, and I can figure that out pretty easily. If you want to take the time to memorize those 3, you could next year, but if you understand where they come from, you can figure it out on your own too. The next functions are called the cofunction. The next identities are called the cofunction identities. And all this says is that if I give you, say, the cosine of 30, this is saying that the cosine of 30 has to be the same thing as sine. What's another name for pi over 2 in degrees? So it's the same thing as the 90 degrees minus whatever this theta was. So this theta was 30. So 90 minus 30. So this is saying that the cosine of 30 should be the same thing as the sine of 60. That's all this is saying. Do you guys remember on the unit circle how that was the case? The sine of 60 was radical 3 over 2, and the cosine of 30 was radical 3 over 2. You should have noticed that pattern. I happen to have a unit circle right here. I'll show you what I'm talking about. Right here's 30 degrees. See how the cosine of 30 is the same as the sine of 60? And here the sine of 60 is the same thing as the cosine of 30. I'm sorry, I said that backwards. The sine of 30 is the same as the cosine of 60. It's always true. Okay. So what if I gave you the sine of 20 degrees? What would that be the same as? What do you think, Charlie? Look at the pattern. The cosine of 30 is the same as the sine of 60, so the sine of 20 is the same as the cosine of what? What do we subtract from? We're subtracting from 90. See how it says pi over 2 minus theta? Pi over 2 minus theta. What's pi over 2? Pi is 180. Divided by 2 is 90. So what's 90 minus 20? All right, check it out. If you go to your calculator, you're not sure you did it right, go to your mode. Make sure you're in degrees. The sine of 20 is this. The cosine of 10, like he said first, is that. Those aren't the same, are they? Then we changed it, cosine of 70. And see how they're exactly the same now? All right. So how else could we do it then? What about, because it works for tangent as well. The tangent of pi over 2 minus theta is the same as the cotangent of theta. So I'm going to give you a minute to figure this one out. What if I said the tangent of pi over 5? So to find what it's equal to the cotangent of, figure out what that angle would be. What do you have to subtract from? Which is in radians? All right, so do pi over 2 minus pi over 5 and tell me what you get. Do the common denominator. What'd you get, Sydney? Good. Okay, so those two would be equivalent to each other. All right, the last thing we have is called the negative angle identities. This says that the sine of negative theta is the same thing as negative sine theta. That's not really intuitive. Let me show you what that really means. Let's say that we're doing theta is 30 degrees. So this would be saying that the sine of negative 30 is the same as negative the sine of 30. Negative 30 just means I'm going to start here and I'm going to go in this direction. So if this is 30 degrees, This would be -1, this would be 2, this would be radical 3. So what is the sine of -30? Everybody? Opposite over hypotenuse, what is it? -1/2 is the sine of -30. Then this would be saying the sine of +30. So 30 degrees going this way, this is 1, this is 2. What's that going to be? Just the sine of 30. So do you see how I would have to put a negative in front of it in order for them to be equal to each other? So that's what it's saying. This has to do with the quadrants. All students take calculus. In this quadrant, everything's positive. In this quadrant, sine is negative. So if I go in this direction and get into this quadrant, it would be equal to the negative of the other one. But look at this one. So this would be saying if I do cosine of -30, it's the same thing as the cosine of +30. Look at it. The cosine of -30 would be adjacent over hypotenuse. The cosine of +30 would be adjacent over hypotenuse. Do you see how they're both positive? They're both radical 3/2. So we don't have to change the sign. If I do tangent, the tangent of -30, opposite over adjacent, -1 over radical 3. +30 though, the angle would be 1 over radical 3. So do you see how I'd have to make it negative to make them equal? All right? That's all that's saying. Yes? That is a good question. Let's test it and see. All right, so let's see if the sine of 120, I'll just do it in degrees, would that be equal to negative sine of 120? So let's draw a picture. 120 goes here. Sorry, I wanted, yeah. Sorry, I was thinking wrong. So this negative 120 would go here, and then 120 would go here. So yeah, that would work. Down here it would be negative, here it would be positive. Yeah, it should always work. You know. So it doesn't matter if it's in between 0 and 90. Because it all has to do with the rotations, and because it's 360, even if it was like negative 240 would put it here, positive 240 would put it here. See what I mean? So it's always going to end up in, one would be in the top quadrant, one would be in the bottom quadrant. So one would be a positive and one would be a negative for sine. Any other questions? Okay, guys, so like I said, if you want to start on a couple of those problems, you can. You've still got like 12 minutes. You should be able to do like the first couple. Oh, wait. I'm sorry. We have to do one. We haven't even done a problem yet. Let's do this problem. All right. So this is saying that the sine of theta is 1/5, and it's saying that theta is in between pi over 2 and pi. We have to draw a picture. This is 0, this is pi over 2, this is pi, this is 3 pi over 2. This can be thought of as 2 pi. So which quadrant are we going to be in if our angle theta has to be in between pi over 2 and pi? The first? First is in between second, right? Pi over 2 and pi would put us in the second quadrant. Now we have to think, what is sine the same as? Is it opposite, adjacent, hypotenuse? What is it? Opposite over hypotenuse. So opposite is going to be 1. Here's our angle. Opposite is 1. Hypotenuse is 5. I'm supposed to find the other 5 trig functions. We're not even going to bother doing this one. So we're going to find the cosine, the tangent, the cotangent, the secant, and the cosecant. Well, in order to find the cosine, I have to do adjacent over hypotenuse. How am I going to find this missing side? What are we going to do? Use the Pythagorean theorem, right? We have a right triangle. So to find that missing side, I'm going to do a squared plus b squared equals c squared. A squared is 24. So what's the square root of 24 simplified? It's 4 times 6, so what is it? 2 radical 6, right, so this is 2 radical 6. Is that going to be on the positive direction for x or the negative? Negative, so it's going to be negative. So my cosine value then is going to be negative 2 radical 6 over 5, adjacent over hypotenuse. My tangent would be opposite over adjacent. And then to fix this, I would just want to multiply by radical 6 to get it rationalized. So I get radical 6 over, radical 6 times radical 6 is 6 times negative 2 is 12. So negative. And then for cotangent, I want to do the reciprocal of this. But instead of flipping this, I would want to flip that. Or I can just go back to my triangle, and instead of doing y over x, I can do x over y. That's the fastest way. There's the cotangent. For the secant, that's the reciprocal of cosine. Or I can just look here and do hypotenuse over adjacent. And then rationalize it. So we get negative 5 radical 6 over 6 times 2 is 12. And then lastly, for the cosecant, well, that's just going to be the reciprocal of sine, so I'm not even going to bother looking at the triangle. The reciprocal of 1/5 is going to be 5. And then I should do a little check. All students take calculus. My ratios in this quadrant, only sine should be positive. If sine is positive, cosecant is positive. Every other ratio should be negative, and it is. Okay? We're going to stop there for today.